Hello, um, good morning to all of us. Thank you for coming to this new session in sets that we are doing. And today we want to look into radical equations. First, let's understand what radical equations are. The word radical, right? We have functional, the words terms that are kind of adjective of some nouns. So if it's function, we say functional, right? So radical, this one is referring to equations that contain roots, contain square roots, because the square root sign that we were saying that we put it under umbrella, we call it that's the radical sign, right? What is under the square root, whatever is under the square root, we call the radicand. Yes. So all these equations that every equation that contains square roots equation that contains square root in such a way that the variable that we are looking for is under the square root. That particular equation can also be termed as a radical equation. So we are expecting that in a radical equation, we are expecting the square root to be involved, and also the variable that is involved is found under the square root. That's when we have a radical equation. Let's have a typical example on our board. Yes, this typical example, I pick it from the Akiola. So we are going to look through the concepts. We are not just going to solve, but we are going to use everything that we have learned so far in order to go through how to solve radical equations. As we said earlier, let's see this if this equation is truly a radical equation. We say a radical equation should be an equation that contains what? Square roots, right? And the variable that we are looking for is under the square root. So let's these are the square roots that are here, and we also see that the variable that we are looking for is x and x is here. So those variables are under the square root. So it can be one. It's not like it's not compulsory for all the two of them to be under the square. Once one of them is under the variable, is a radical equation. Yeah, as an equation because we are doing an equal to sign. That's why it's called an equation. And then radical equations is like the radical, the roots. Fine. Now, how do we solve this? From the previous video, we realized that is we are not comfortable working with square roots. So we need to find a way to get rid of the square roots first. That's the first step. When we did the equality of sets, when we get to some point, we realize that we have to get rid of the square root. So what do? We square both sides, right? But we are focusing on removing the square root. If we go ahead and say, okay, let's square both sides like this. So we square both sides, and then we also square this side. We are going to see that this squaring that we are doing, squaring both sides. The reason why we are doing squaring of both sides is to make sure that at the end of the day we can eliminate a particular square root. But in this case, if we square both sides this way, we will see that this square root that we are doing, these two cannot eliminate any of the square roots. Why? If you watch our previous videos, you will understand that you can only eliminate when you are squaring both sides, you can only eliminate the square root with the square sign, the square index when everything under the square root and everything in the square root is under one square root umbrella. But here they are not under the same square root umbrella. What can we do? We see that this square root is here minus this other one. They are not under one of them. So it's impossible to do that. There's no other way that we can do that. So what we have to do is that we don't have to go through this step. We don't have to go and then square both sides at once. The easier way of handling this is to make sure that we have one component that is having the square root on one side and push the other to the other side. So in this case, I'll try and push this guy to the other side of the equation so I can have only this square root here. So you need to make sure you have only one on one side. That will make the work easy for you. So you have 3x plus 4 will be equal to, so I'm sending this whole entire square root to the other side. So it's minus here, so it become plus square root of x plus 5. Now in this case, you can see that you have the square root, one square root component at one side, right? So in this case, after doing that, now we can square both sides. So let's square both sides. So what's the reason? So squaring both sides, may remember we are doing square of everything in this side on the left side and square root of everything on the other side. Don't just go and do square root of 1 plus square root of 2 separately on the other side. It's everything. So everything, whatever you are doing here, you do it on the other side. So the reason we are doing the square roots or finding the square of both sides is because we want to eliminate the square roots. So you see that in this case, this square root that we are having, this power 2 that we are having, can eliminate this square root because everything in the bracket that this number 2 is squaring, all of them are under one umbrella of the square root. So it is easy to do that. So this square root can be eliminated by these two. At the end of the day, this is simplified to 3x plus 4. It will be equal to, but on this side, these two cannot eliminate it because we don't have everything under one umbrella inside the bracket that we are squaring. So we need to do what? Expansion. We said that in the previous video. Kindly watch that and go through. So if you do the expansion, you take your time and do your expansion, we have this plus x plus 5 plus 2 square root of x plus 5. So this is what we get after the expansion. Then we simplify. I have 3x plus 4 will be equal to x, x here. So I have 5 and 1 plus 6 plus 2 square root of x plus 5. Yeah, you may ask why this 2 is not being added. You watch the previous videos. Always follow us as you are building up concepts, because one video follow the other explaining the concept. So those concepts what we are using here. There are no concepts here that we are using that we have not explained. So watch the video systematically in order to understand what we are doing at this point. If you have any question, you can ask us in the comment section. So yeah, this is what we have now. We need to group like terms, right? Because now we are still seeing the square root inside our equation. We are still having a radical equation, which we don't want. We want to eliminate them. We easily find x. So what happens is that we need to make sure that we have square roots on one side and put everything on the other side. We want to have the square root component on one side and put every other thing in the on the other side. You do that anytime you want to eliminate a particular square root at a time. You do that whenever you want to eliminate a particular square root at a time. So we don't want a square root. So we are going to put everything on the other side. So all these components here that we are having that are not associated with the square root, we are sending them to this side. So if you do that, you are going to have 3s plus 4, which is already here. The s that is coming minus 6 will be equal to 2 square root of x plus 5. What's the reason why we did that? Because we want to have the square root on one side of the equation. Now, so 3s minus s will give us 2x, and then positive x, positive 4 minus 6 will give us negative 2, which is equal to 2 square root of x plus 5. Wow, this is simple. We can divide it through by 2, right? You can easily divide through by 2. So if you divide through by 2, we have x minus 1 is equal to square root of x plus 5. Now successfully we have an equation on one side of the square root on one side of the equation. So what should happen? We need to square both sides again. Anytime we want to eliminate the square root, we need to make sure that we square both sides. So I'm going to square both sides, square both sides. The reason we are squaring the both sides again is because we want to get rid of the square root sign. So before you can do that, you need to make sure that we have the square root sign and its component on one side. That's when we can do that. So if we are doing that, you will see that at this point, we have to expand s squared, s minus 1 all squared. So if we expand that, we are going to have this minus 2x equals to, if you square this guy, this 2 will just eliminate this, because that's what we are even looking for. Whenever you have a square on or entirely on a particular square root sign, what are we having? You can easily eliminate it as we have explained earlier. At the end of the day, we just have x plus 5 over here. Now, bravo, we have all the square roots that are gone from our equation. All the square root signs are gone from our equation. So we now have to just simply simplify. So let's try to simplify this. Um, Now we have to do our factorization and simply do what we regularly do. So I'll put everything on one side so that it will be easy for me. S squared minus 2s minus x plus 1 minus 5 equals to 0. So I have s squared minus 3x minus 4 equals to 0. Now at this point, we have a form that we can easily factorize. We have a form that we can easily factorize. I explained that we will do factorization when we are handling functions. We will focus on factorization and be able to factorize. For the meantime, you can go ahead and practice how to factorize for the meantime before we get those videos ready for you, or those series of videos ready for you. But then here we are going to use a factorization idea to easily factorize. So if you factorize in this case, um, let's see, I think we are going to have x minus 4, I guess, yes, multiplying x plus 1 equals to 0. This is the equation that this is the factorized form that we have now. So now let's if you solve this, this is how to solve factorized form to is equal 0, or x plus 1 equals to 0. So we have x is equal to 4, or x is equal to negative 1. So we have two values for x at the end of the day. We have two values of x at the end of the day. Wow. Two values of x. But for solving radical equations, we have to be careful. After solving, we need not to just run and say, oh, that's our answer. It won't be correct. It will always not be correct. We need to do an extra thing even after having our answers. What we have to do is we have to test if what we found satisfy the equation that they gave us at the start. So we have two answers, right? Let's test if it will really be correct if we use any of the equation. Sometimes, if you do the test, sometimes one of them is not correct, but the one is correct. Sometimes all of them correct. All of them are correct. So we accept both. But then at this point, when you get the final answers x, 4, and 1, you don't have to continue and say, oh, that's your final answer. You lose mark because you didn't test. So let's go to the testing. So let me clean this side so that we put it back so you can clearly see what we had. Let's do the testing now. Yes. So let me eliminate clear this space for us to clearly see what we have to do. So testing, during the testing, what you have to do is just to simply put the value. So we have x is equal to 4, right? And s is equal to 1. So now I'm going to put s is equal to negative 1. Sorry. So I'm going to put 4 inside first. So let's say when x is equal to 4, let's put inside the equation. So let's say we have square root of 3 times 4, which is the x plus 4, minus square root of, we now have 4 plus 5. Hey, what would this give us? So this first one will give us 12 plus 4. Yes, and then minus square root of 4 plus 5 is 9. What will I give us? So this one will give us 12 plus 4 is 16, minus square root of 9 is 3. Remember, we are doing the positive square roots. So square root of 16 is 4. 4 minus 3 is equal to 1. So you see that what we put 4 inside, we got 1. And the equation is saying, giving us, we should have a 1 at the end of the day whenever we put something inside. So it's satisfied. So x is equal to 4 is a valid answer. So x is equal to 4 is valid. Yeah, we have that one correct. Let's test for 1. Let's test for negative 1 because that's the other answer that we have. So let's clear this space and also do the testing for x is equal to negative 1. So when x is equal to negative 1, yes, let's say when x equals to negative 1, what do we have? We have square root of, into bracket, 3 negative 1, because that's the x, plus 4 minus square root of negative 1 plus 5. So if this one will be equal to square root of, at the end of this one is negative 3 plus 4 under this bracket minus square root of negative 1 plus 5. That will give us 4. So if we do that, let me clear the bottom here so you can clearly see what we are doing. Then what do we have? So negative 3 plus 4 will give us 1 here minus square root of 4. Square root of 1 is 1 minus square root of 4 is 2. So square root of 2, so we have 1 minus 2. So 1 minus 2 gave us negative 1. So at the end of the day, when we put negative 1 inside, the answer we got is negative 1. And that negative 1 is not the expected result 1 that we have. So the negative 1 didn't give us the 1 that we have. At the end of the day, we see that when s is equal to negative 1, s is equal to negative 1 is not correct. It's not going to work for us. So the only answer that's valid from the two answers that we got is s is equal to 4. So at the end of the day, the final answer for this particular radical equation is s is equal to 4. This is our final answer. This is our final answer because s is equal to negative 1 will not satisfy that. So this is how to solve the radical equation.